Hello everyone. In this video I want to tell you a little bit about how to call C++ code from inside of Python. Now this functionality you're probably not going to use 98% of the time, but it's important to know that it exists just in case you end up writing a program where you really need one part of the program to be super fast for some reason. In my experience, I found this functionality to be relatively difficult to debug, but yet very useful in some research projects. And there's a number of ways to do this. I'm going to tell you basically 3 ways that you might go about doing it in this video. So the first way that I want to introduce to you is the scipy.weave package. So let's just do a little example here as an introduction. So we're just going to import scipy.weave. I'm going to create an array A, and I'm going to store the length of that array in just an integer here that I'm going to call my length. Then the way that you have Python call your C++ code with weave is to just store the C++ code in a string. So here it is. This is my string C++ code. And let's read over it. So in the code, I'm just going to have a little for loop. It creates a local integer I. I'm creating this integer inside the C++ code. It's looping until I is less than my length, incrementing I at every point. And then it's going to do a little print that prints out the value of I. Main thing that I want to point out to you is that here I have to have a double backslash. So this is different than if you were typing C++ code directly into a file and then compiling it, because this is a Python string. And so the same way as everything, as all strings in Python, if you actually want a backslash in that Python string, you have to put in a double backslash. So that's why we're putting this double backslash n to print I. And then what I'm going to do is take that array A and look at the ith element of it and increment it by 1. So at this point, this my C++ code is just a string. And then what I'm going to do to call that code is just call scipy.weave inline, pass in that string C++ code, and then pass in the names of the 2 variables I want to pass into that C++ code. So in this particular case, it's A, that array I created, and mylen, which is that length variable of A. And I say verbose equals 2 because I want some more printout statements about what happens. So let me just paste this code into Python so that we can see what happens. So here it is, I'm pasting it. And what I want you to know is that when this inline statement first gets executed, what happens is Python in the background is going to go off and compile that C++ code. So the first time you call it, it compiles it, and then the second time you happen to call the same code with the same types of variables. In this particular case, the 2 types are an array of integers and an integer. Then it's not going to compile any time after that. So the first execution is slow, but the following executions are fast. Now let's see what happened when this inline statement got called. Here I got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those things came from this printf statement. So that's printing the value of I in each iteration of the for loop. And just to remind you, at the beginning here we had A be just an array of integers 0 through 9. So let's take a look at the value of A at the end of this executing this inline statement. So now you can see it's 1 through 10. That's because we incremented A as we went through the for loop. So if I called this inline statement again we're getting the 0 through 9, and if I look at A, now it's 2 through 11. So it actually incremented the various things. So this is an example of calling some C++ code from inside of Python, and you can put in arbitrary C++ code. And by the way, there's ways that you can interact with all of the native Python data types. You can interact with lists, dictionaries, etc. that you might want to pass into that C++ code. Just to show you a little bit about compilation, so let's say that, let me change A to be A range 10, but let me give the data type to be float. So here it is A. So this is a different data type. So it's an array of floats instead of an array of integers. So now when I call inline, you'll notice that the first thing that happened was a bunch of compilations. So this is because in that translation to C++, the data type of the variables that you pass in is critical because I have to have different functions for different data types, or if I'm compiling a templated type code, I still have to compile it multiple times for different data types. So what happened is the code got recompiled, but this time for an array of floats instead of an array of integers. And if I look at A, now it's an array of floats that got incremented by 1 from the original array, which was just 0 through 9. So that's just one example. But just to give you another example, you can also just compile a C++ function and call it multiple times in your code if you want. So, of course, it's going to recompile every time depending on the data types that you pass into that function. And this function is a little example of interacting with the native Python data types. So let's just read through the function. So this is just a really dumb little example function. So we're going to call it myC function. It takes in two inputs, A and B. And then the code is, first we create a tuple that we're going to call answer. And this tuple is just going to have two values in it. And I'm going to say answer 0 is A and answer 1 is B. And the return value of the function is going to be whatever that answer tuple is. And then here I'm going to say return scipy weave inline that code, and I'm going to pass in the values A and B. So let me paste this and call it. So here I define my C function. So let's call my C function with two values, 3 and 4. So what I expect the return value of this to be the tuple 3, 4. So let's call my C function again with 3 and then the string 4. Now you notice when I'll call it this time, it's going to recompile because it's different data types for A and B. But again, I'm going to get the return value, that's the tuple 3 and then the string 4. Or I could do 3 and then 4, and there's some recompilation that happening, and then 3 and 4. So the next time I call it, of course, it doesn't recompile because it's already compiled that in the back, and so now I'm getting that fast C++ execution as opposed to the native Python execution. So just to show you a little bit of where you might find more about the Weave module, you can just look at the Scipy documentation for this, and this is quite extensive with lots and lots of examples. It'll also tell you some comparisons in terms of how fast the native Python code is compared to this scipy.weave code. So you might get speedups of anywhere between 1.5 to 82 times, depending on the type of code that you have. But of course, the trade-off that you're giving for this speedup is that it's much harder to debug this code, and it's a lot less flexible in general. But the other things to look for in this documentation that are quite useful are things like this, which is passing in a dictionary to your C++ code and interacting with methods from that dictionary. So here, adict is a dictionary that got passed into the C++ code, and here we're pulling out the keys from that, and that's a Python list, and so forth. So you have all of the functionality of Python inside your C++ code, but it's a little bit hard to use. So for example, here is getting an item out of a dictionary, or here is getting an item out of a list. So these are things that you can take a look at. In addition to building in this C++ code, Scipy Weave package has something called Blitz. So just to give you an example of Blitz, and you can read the example code yourself, what Blitz does is it takes some Scipy array code like this and automatically creates the equivalent C code for it. And by doing this, you can get significant speedups in how fast your code executes. Now, again, you're likely to not need this functionality unless you're building something that really needs super fast code. But it's good to know that it's there, and the scipy.blitz functionality is a lot easier to use than writing your own C++ code. So in particular, you'll notice that this string looks exactly like the Scipy code that you would write, except what happens in the background is that expression gets turned into C code, and that C code gets executed as opposed to the native Python code. And this can be, again, significantly faster, and you can read the Weave documentation to find out more about exactly how much faster it is. Now, the last thing that I want to tell you about calling C code from inside of Python, or C++ code from inside of Python, is the swig set of programs. So you can find documentation about these on swig.org. And just a quick overview of this. You can have an arbitrary C or C++ function. So for example, this is a function that just computes factorials. It takes an integer, it returns an integer. So this should look very familiar to those of you who've done C or C++ coding before. And in addition to this code, you define a little swig file. So this swig file essentially tells swig which are the functions that you want to expose to Python. And in particular, we're doing that with this line where we're saying we want to expose this factorial function. Then what happens is you run swig with some command line. So swig is a program. You run it from the command line. You can read the various documentation for it. But as input to that, you pass in that example.i file. So that's this file that says which C functions we want to expose to Python. And at the end of that, what happens is what gets created is a little Python module that you can import. That module is going to have this factorial function in it, and it's going to be, you can call it by passing integers into it from Python, and it can run much faster than the equivalent native Python code. So again, I'm not going into very much details about this, but it's good to know that this functionality exists. So one downside to using this functionality, just in case you're thinking about using it, is that if you pass in the wrong kinds of arguments, your program is going to fail with a segmentation fault. This is a very ungraceful way to fail as compared to something like throwing an exception, which you might be used to from programming native Python code. So the downsides are it's a lot harder to debug. If it fails, it just fails with a segmentation fault, and you might not know exactly where the error is. But the upside is that you get significantly faster code, and that you can call arbitrary C++ or C libraries from inside of Python. So I hope you find this functionality useful, and thank you very much for listening.